Lab 2, Motion of a Falling Object. Introduction. In this experiment, an object was dropped and recorded. This video is then put into Tracker to have data on position, time, and velocity extracted. The initial position and velocities were then used to create computational models in GlowScript. These models were used to predict a path of motion and predict how far the object would travel. This experiment aimed to compare the observed motion to that of two varieties, one of just gravity, Model 1, and one with gravity and drag, Model 2. The main law governing this experiment was Newton's second law. The results found that modeled motion were very similar to what was observed. The difference was for the Model 1, the final position was slightly overestimated. Model overview. The blue dots represent the observed position, while the red dots represent Model 1 and the yellow dots represent Model 2. There's great overlap in the positions. As previously stated, Newton's second law plays a large role in this experiment. This law relates force to an object's mass and acceleration. An object's acceleration is caused by its mass and forces acting upon it. Newton's second law was chosen for this experiment to investigate the effect of drag force and weight force on acceleration. This equation can be rearranged and rewritten to give velocity update formula. The final velocity can then be used to give new position via the position update formula. The formulas for drag force and force of gravity or weight force are given below. The sum of these forces is F net. The assumptions are that only these two forces are in play for Model 2, while gravity or weight force is the only force in play for Model 1. Motion is only being tracked along the y-axis as well. The system is a foam object while the surroundings were everything else around it. Initial position was 0, with the initial velocity for y being negative 0.132 meters per second. In the experiment, the foam object was held and let go. This was recorded, and position and velocity data in relation to time was extracted. The model used initial velocity and position as well as time travel to generate a path of motion for the object. Model 1 investigated the effect of just weight force on motion, while Model 2 incorporated drag force as well. Here's a snippet of code for Model 1. Initial position is set to 0, and the initial velocity is set to negative 0.132 meters per second for the y component and 0.185 meters per second for the x component. The x component is incorporated due to slight drift along the x-axis. Delta t was chosen based on the time increment from Tracker to be as close to the observational data as possible. 0.633 seconds is the total time the object moved. Newton's second law velocity update formula is used in line 77, while position update is used in line 79. Calculation for weight force is seen in line 70. Most of the information from the previous model was used here as well. In addition to the information for Model 1, calculation for weight force is seen in line 70, while drag force is in line 72 and 73. The B value was chosen empirically by trial and error. Results and discussion. Both models are very similar and accurate to what was observed. The only difference was that in earlier times, Model 2 and Model 1 overshot the position, and while in final times, Model 1 overestimated position slightly. Possible errors could come from not accounting for any other forces that may have been in play, such as using slight force to move the object downwards. Inaccurate data collection with Tracker also may have altered results. Drifting along the z-axis that wasn't taken into account may have warped potential measurements as well. What does it mean? Terminal velocity occurs when drag force is equal to the force of gravity, meaning F net is 0. This in turn creates a constant velocity with position changing proportionally to time. This was not observed in any model, as velocity never stayed constant for any period of time that was in the models. What if the object was initially thrown? This throwing would have caused the initial velocity to be greater, as there's a greater force behind its descent. However, this will not change the terminal velocity. Terminal velocity is a result of weight force being balanced by drag, and this weight force is not manipulated. If the weight of the object was manipulated instead, this would change terminal velocity. In conclusion, both models were very similar and accurate to observed motion. However, Model 1 was slightly inaccurate as it overestimated positions, while Model 2 was much more accurate to what was observed.